All right, in this video, we're going to look at writing the first 5 terms of sequences that involve our new factorial notation. And for these problems, instead of letting our first value be a sub 1, we're actually going to let our first value start with n equals 0. So our first term, instead of being a sub 1 equals whatever we get when we plugged 1 in, when we do our first term, we're actually going to find a sub 0, and we're going to replace n with 0. Now, just like you did before, you're going to generate your terms by just substituting in given values for your variable and doing the math. And in the fraction, when we have these types of problems, you just treat the numerator and denominator like separate problems, and you build a fraction as you go. So if I'm trying to find my first term and I'm letting n equal 0, I'm going to find a sub 0. So a sub 0, I'm going to go in here and I'm going to replace my n's with 0. So my numerator is going to become 3 to the 0 power plus 1, and my denominator is going to be 0 factorial. Now, from your properties of exponents, you should remember that anything raised to the 0 power is 1. So we're going to get 1 plus 1 in our numerator. And 0 factorial is that special factorial where 0 factorial is equal to 1. So now we just have to simplify the numerator. 1 plus 1 is 2. Our denominator is still 1. And then 2 divided by 1 is just 2. So there's our first term. So we want to generate the first 5 terms. So we're just going to keep repeating this process until we have 5 numbers in a row. Our first value was 2. So we're going to go ahead and find our next value. To get our second term, we're going to go to the next integer. So we're going to go up to 1. So I'm going to go into that formula, replace my n's with 1. So in my numerator, I'm going to have 3 to the first plus 1. And in my denominator, I'm going to have 1 factorial. 3 to the first is 3. 3 plus 1 is 4. And then for our factorial, we start with 1 and we multiply by increasing integers until we get to that value. But for this problem, we're going to start with 1 and end with 1. So our fraction is 4 divided by 1, or just 4. So the second term in my sequence is 4. All right. To get my third term, I'm going to go to the next integer, which would be 2. So I'm going to replace n's in my numerator and denominator there with 2. So I'm going to get in my numerator 3 squared plus 1. And in my denominator, I'm going to get 2 factorial. 3 squared is 9. 9 plus 1 is 10. And then for 2 factorial, I'm going to start with 1 and multiply by increasing integers until I get to 2. So I just get 1 times 2. That is just 2 in my denominator. So 10 divided by 2 is 5. So my third term is 5. I have 2 more to go. So for my fourth term, I'm going to find a sub 3. So I'm going to replace n's with 3. So I'm going to get 3 to the third plus 1 over 3 factorial. 3 to the third is 27. 27 plus 1 is 28. And then for 3 factorial, we're going to get 1 times 2 times 3. That's going to give me 6. And then 28 divided by 6, I can reduce that fraction. They're both even values. So I'm going to divide them both by 2. That's going to give me 14 thirds. And I'm going to leave that as an improper fraction. We don't need to worry about mixed numbers for these guys. All right. And then lastly, my fifth term, I'm going to replace my n's with 4. So I'm going to get 3 to the fourth plus 1 and then 4 factorial. So 3 to the fourth is 81. 81 plus 1 is 82. 4 factorial is 1 times 2 times 3 times 4. I'm going to get 82 over 24. And again, I'm going to reduce that. They're both even numbers. They both divide by 2. So I'm going to get 41 over 12. And again, I'm going to keep it like that. And there we have our first 5 terms of our sequence using our new factorial notation. Now, as we're going through and we're trying to simplify these, when we're working through problems, we still have to apply order of operations. So if we see something in parentheses, we actually have to do that math first before we can apply the outside rules. So for this case right here in my denominator where I see 2n in parentheses, I actually have to do that multiplying, and then I'm going to apply my factorial rule to that. So we're going to find the first 5 terms of this sequence, which again, we're going to treat the numerator and denominator and then just build our fraction. As I go in, they again want me to find my first term by letting n equal 0. So for my first term, a sub 0. In my numerator, I'm going to get -1 in parentheses, and I'm going to raise that to the 2 times 0, or 0 power. In my denominator, I'm going to have 2 times 0. 2 times 0 is 0. So my new fraction now, as I replace those ends, I get -1, that quantity raised to the 0 power. And again, just like we saw before, anything raised to the 0 power is 1. And 0 factorial is that special case that equals 1. So my first term in this sequence is going to be 1. For my second term, I'm going to find a sub 1. So again, I'm going to go back here and I'm going to replace these ends with 1. So I'm going to do 2 times 1 to get an exponent of 2 there. So I'm going to get -1 squared. And then in my denominator, I'm going to do 2 times 1, which is 2. So this is going to be 2 factorial. So I'm going to get +1, because a negative squared would be a +1. 1 times 2 would be 2 factorial. So we're going to get 1/2 as our second term. For our third term, we're going to find a sub 2. So I'm going to replace my ends with 2. So my exponent up here is going to be 2 times 2, which is 4. So my numerator is going to have that quantity of -1 raised to the 4th. This I'm going to do 2 times 2, which is still 4. So this is going to be 4 factorial. So my numerator is going to be a +1 again, because a negative raised to an even power would stay positive. And 4 factorial is 1 times 2 times 3 times 4. We found that up here to be 24. So my next term is going to be 1/24. Again, we have 2 more to go. So my next one, I'm going to find my third term. I'm going to find a sub 3. So I'm going to replace ends in this formula with 3. So 2 times 3 is 6. So I'm going to get in my numerator that quantity of -1 raised to the 6th. And down here, 2 times 3 is 6. I'm going to get 6 factorial. Again, my numerator is going to stay +1, because I have -1 again raised to that even power of 6. But for 6 factorial, I'm going to take 1 times 2 times 3 times 4 times 5 times 6. Remember, we start with 1 and we keep multiplying by the increasing integers until we get to the given value, in this case 6. So when we work that out, this ends up giving us 720 in that denominator. So my next term is 1/720, and we've got one last one to find. So for my last term, my fifth term, I'm going to find a sub 4. So I'm going to go back to my rule and replace n with 4. So I'm going to get 8 for those values. So I'm going to get -1 to the 8th power up there, and then I'm going to get 8 factorial. Again, +1, and then I'm going to get 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. And that's going to give me 1/40,320. So my last term for that sequence would be 40,320, and there are my first 5 terms. So notice again, I had to apply my order of operations. I had to apply the math in parentheses first, and then use our new rule for the factorial. And again, to evaluate a factorial, you start with 1, and you multiply by the increasing integers until you get to your given value. So for factorial, I started with 1, and I multiplied by 2 times 3 times 4. For 8 factorial, I started with 1, and I multiplied all the way up until I got all the integers from 1 to 8. And then I just let my calculator do that. Not work for me. That's crazy. All right. So when you're working through, you're going to be solving some similar problems with these, and let me know if you have any questions.